what we will do today is we'll continue the goal we've started last time on linear regression and correlation. Okay, so we'll just give you an overview of what we've seen so far and what we will be doing next. And I will introduce today a new software called GeoGebra as a tool to teach statistics. So what are the goals for this learning outcome? So first, you will have to understand and to know what is dependent, independent variable. That we've seen already. Okay, when you want to have a correlation between two things, okay, you have a dependent, independent variable. The first thing to do when you want to see a correlation is to draw a scatter diagram. Okay, we did last time a few examples on scatter diagram. And what will be new today is how we calculate and interpret the coefficient of correlation and the coefficient of determination. Of course, I will explain the meaning of both. And this one will be for next class. It will be how to calculate the line of best fit. You know, if you have a linear relationship between two variables, it means you can draw a line. Okay, and what will be the line of best fit? And the very last step will be to predict value from this line. So some example, why do we use regression analysis? So for example, is there any relation between your test grade and your attendance? Yes, we'll see. We'll see what kind of relation you have. Do you have any relation between outdoor temperature and the number of ice cream that will be sold on one day? Okay, what about this one? Relation between your IQ and your height. IQ, you know, if IQ score and your height. And finally, it's just for example here, what was the size of an order and the cost to produce these items? Okay, is there any relation? Okay, it's things you may have to use during your professional life. So as we've seen last time, the first thing you have to start with is to do a scatter diagram. Okay, scatter diagram means what? You have two variables. We'll define the two variables, and you plot the points. And we'll see how the points are related to each other. And that's the first step usually we do in correlation analysis. So what are the two variables? The dependent. Okay, so it's the variable being predicted or estimated, and the independent. So for example, in your grade test and your attendance, which one would be independent and dependent? What depends on what? The grade depends on your attendance. Okay, so now let's see how it goes. So I will switch to this GeoGebra. I have here some data ready for you. So few examples. So first, the first one, number of absence and test grade. So you said yes, there is a relation between, yes? So let's have a look. If I select the data here, I can do a scatter diagram right away by just a click. And this is what I get. So what do you see here? What kind of relation? So I have the independent variable as the x variable. Okay, so the number of absence. And the dependent, it's your grade. So do you see any relationship between the two? Exactly. It seems to be, what, do you recognize a curve? It's negative. Okay, it means if the number of absence is increasing, your grade is decreasing. Okay, so it's a negative relationship. And what can you draw here? Do you see if we can draw like a parabola or a line? Exactly. So most probably this one will be a linear negative relationship. Okay, and we have some model here. We can see if it fits. Okay, so regression model can be anything. It can be linear, polynomial, a power formula. It's the one that fits the best your results. So you're telling me it's maybe linear, so let's have a look. Yes. Okay, so you have a nice line that seems to predict your variable, your data. Our value of x and y, that's the one done with your attendance and your grade. Okay, so as you said, we need to find x squared. Y squared, okay, so it's been done for you, and the product of x and y. Y squared minus all square, and I will close the bracket. And everything is under the root. Okay, so let's do again, step by step. Let's find the numerator first. What will be the numerator? Numerator, it's on the top, yes? So what do I have? So my numerator will be... Okay, so n, how many values do I have? 16, that's correct, yes. It said here, good guess, but it's 16, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 16. A linear relationship, if it's a strong or a weak, linear, okay, linear, you recognize the word line, okay, for a line. And it's giving you the direction, if it's minus or plus. Okay, so it's giving you the trend. The R square, it's just give you, if your model is good, the percentage of data that are explained by the model. Like here, do you think it will be a good line? No. And it's true, because look, we have a R of 0.3052. So, in terms of R square, it means what percentage of data can you explain with this line? So I square my R and I find 0.09. So it's useless. No? What do you think? If you have a line, but this line can explain only 9% of your data, it means what? It means 91%, no, 91%, sorry. Khalas, you can't explain. So you won't be able to explain why I have a point here, why I have here. So you can't do any good correlation. So that's why when we decide to find the equation of the line, we will do it only if R is significant. Okay, like here, R is not significant. So if you have a question like this, and they said, okay, you need to find R, and if R is significant, you complete and you give me the equation of the line. Would you complete here? No. Exactly. You will tell me, okay, no, teacher, I'm sorry, but R is not significant. I'm not going to find the equation of the line that I will use only for 9% of my data. Okay, because it's useless. So it's better to find the equation of a line when the value of R is significant, like the few examples we've seen at the beginning. Okay, this one, of course,